Hello.
How are things in Canada?
Things are good, mostly.
Excellent. Everybody had their government-appointed poutine?
Poutine and parkas, everything. Yeah.
Neat. I can actually see everybody. This is very close to the native meetup experience. Hello, everyone.
Good. Excellent. Can you hear us okay?
I sure can.
Okay. Then I'm going to go full screen, which will probably hang my computer for 30 seconds. And if this works, then we're ready to go.
Cool.
We're ready.
Nice.
Oh, man. I can't get over how I can actually see this. So, I've done, I think, one or two of these remote meetup things, and I think I did one for a group in the Netherlands, actually. And I was terrified because I couldn't really see or understand anyone, and I'm pretty sure I bombed it. But I'll never really know. So, please, make a motion or raise your hand or speak up or whatever if you have difficulty understanding me or seeing the screen or anything like that, because this is we're living probably 2 years in the future right now and sort of perilous.
Yes, it is.
So I don't know a whole lot about how this group normally runs. Dan has told me a little bit about the way they go, and the thing I agreed to was talk a little bit about Hoplon and show some code, and then talk about the code.
Yep.
But before I do that, I understand y'all have already been there for like a half an hour, and it occurs to me you may have accumulated questions already, so I'd be happy to answer any questions you might have right now before I start.
Yeah, we do. Well, I actually have some questions from the video yesterday, but actually the first hour of our meetup today was taken up learning about a new FRP library in Clojure.
Oh.
It's a port of Elm to Clojure called
Zelkova
that James here wrote.
Awesome.
Yeah, very, very cool. Just launched today, and it's a very cool system.
And I wanted to thank you actually because there is some of your code in it. I used the con algorithm that you put up in a gist to do topological sorts.
Cool. I'm glad you enjoyed it. Yeah, I guess if you do Elm, you have probably static data flow, so you could.
Yeah, exactly.
The con. Awesome. Yeah, I should have patented that code or something. Somebody the other day was like, "Hey, congratulations on your contribution to Light Table." I'm like, "Light Table, dude, I use Emacs." It's like, "Oh, the consort thing is in there." But no, Light Table is really cool. Neat. Well, that's actually sort of a great intro because I think the place I started on this quest of reactive programming exploration was with FRP probably 2 or 3 years ago. Mm-hmm. Reactive wasn't yet a manifesto, but I would say even those of us working in the enlightened compiled to JavaScript languages, we're still sort of wanting for the answer. So if everyone would travel back with me now to about 2010, Backbone had just come out, CoffeeScript was getting popular, a Google Clojure compiler had just been open sourced, and a book came out about Google Clojure compiler. And there was a sense, at least among the idiots of Hacker News, that the web application problem was close to being solved. Like, we're really worked our way to the essential things, and the essential things are, you use an MVC front end or MVCC or whatever, whether you're using Knockout or whatever. And then you have your MVC backend. Now you have this beautiful abstraction where you can map objects in JavaScript world to tables in your database, which is obviously a great idea. Yeah, so I mean, I've been butting heads with this problem for a long time. So I'm one of those hyper-privileged suburban white kids who had a computer from age 2, and I had a homepage at 10 and all this crap. But one thing that was persistently irritating, I think, about the web stuff is that I made a lot of homepages and JavaScript programs, but even once I started doing it professionally, I never felt great about them. They were never really a home run. They were always really difficult to maintain. Part of that is that the web standards are constantly evolving, so you know, it's like inflation or something. Like there's a change in your app program that you have no part in, which is the browser environment shifting. So, but the other part of it, you know, I think is the fact that none of these tools that we're working with were ever really designed at all. The web wasn't designed, and if you could argue it was, but it definitely wasn't designed for anything we do. I mean, it was designed to share scientific documents, which is you know, I've never even done that, so I don't know. You know, maybe it's good at that, but and then, you know, there's of course the whole JavaScript story, and JavaScript is this kind of thing that Brendan Eich had to code up in a week to keep his job or whatever the story is. And now, with all these people, you know, a lot of people make their livings, and a lot of businesses make a lot of money off the web. So now there are millions of voices and millions of developer advocates and strange marketing plots and various embezzlement schemes, and it's not really clear what's going on. Right. Google's involved, of course, and they have like 2 or 3 major frameworks that they're forwarding, and some of which they use, but we're not sure. So it's definitely murky territory. So Hoplon is my longtime friend and sort of open source. I'll call him the sidekick. He's the sidekick. You know, it's our sort of shot in the dark, like trying to solve the problems that we've run up against and trying to come up with a way of building these apps that, you know, we can feel good about. I think something that we all may have noticed is that when it comes down to it, other than, you know, the mathematical foundation of, you know, that Turing laid down with how computers work and lambda calculus and things like that, beyond that, it's all taste. You either like it or you don't. I mean, we can make fuzzy arguments about what's better and what's not. We can make fun of MVC. We can make fun of Haskell. You know, at the end of the day, it's what you like to use and what you feel good about using and what works for you. So, if anything, I think it's good. There are a lot of things out there. Elm is one of those things where that's a dude who he decided how he was going to program, and he made a whole world. Chuck Moore with Forth is another sort of character like that. Lisp machines are like that. Everything basically is just, you know, a handful of people with some vision make a thing that they think is cool. So I'm honored here to talk to you tonight about the thing that I think is cool, and that is Hoplon. So, so I mentioned I'd been butting heads with this problem space and this platform for a while. I think I started programming professionally in 2008. And always on the web. I mean, I knew HTML and stuff. And I think I was using... so around the time when ClojureScript came out, I worked for... they were called Relevance, now they're called Cognitech, this company here in Durham. And we were working on this top-secret project, the ClojureScript compiler. And spirits were extremely high because, you know, this seemed like this was the weapon that would finally slay all these problems I've been dealing with for you know, 20 years at that point. And one of the bummers about it was that, like, once it was working, it was kind of more of the same, like callbacks everywhere, you know, dealing with old browser versions, and it became clear to me at that time that the problem was not really the language. That didn't really help, but that wasn't the fundamental issue. It seemed at the time that the big problem was that the browser didn't constitute a unified environment. HTML was its own world, the JavaScript runtime is its own world, and CSS is its own world. So it seemed to me at the time that the way to solve the problem was to unify these things somehow. And certainly a lot of people do this. I mean, Elm does this. There's a certain unification and view of the platform that Elm does that is comprehensive. And there are, if any of you went to Strangeloop or follow what's happening with experimental languages, there are a lot of, Dart is kind of an example of a compile-to-platform language that compiles to more than just JavaScript sometimes. And, which is cool, that's a way to go about it, but I discovered that, you know, it's actually really useful that there's like a bazillion jQuery plugins. And if I use Elm, it's actually really hard to use a jQuery plugin. Elm actually has particularly strange interoperation conventions because you have to box up and validate the data coming to and from the Elm environment. And I knew that that's, you know, this is my job and I'd like to be reasonably quick at it, and I knew that, you know, I save time by using other people's work. So whatever I come up with, it needs to interoperate with existing stuff. And also with existing people. I realized that, you know, I don't always work on a team of like hardcore Lisp people. In fact, I never do. I mean, it's always one or two programmers and one or two designers and a project manager. And usually the designers are the ones that make the product. You know, the people who design the products are the ones who make or break it. So it seemed really important that they're able to work within whatever framework, you know, is the answer. So Misha Niskin and I were working at a company where we were up against the problem again, and we had designers, and we had a particular constraint. We needed to not just rewrite a big web application, but we needed to rewrite it so that its logic could be reused across different white label front ends. So we had several designers who their job was to change the way the application looked, and our job as the programmers was to maintain the way it behaved. You know, which sounded terrifying at the time because that's like the holy grail. Like, okay, so all we need to do is separate logic from presentation. Sounds easy.
Right.
But you know, this is where the money is made. This is why these frameworks exist. So we flailed around for about a year there and came up with Javelin. Part of that flailing involved a dive into FRP, this thing from Haskell called Reactive Banana, which is, I mean, has a cool name.
Yeah.
And then probably the most influential thing that we looked at the time was this thing called Flapjacks, which is a really nice and nicely documented FRP library for JavaScript. So FRP was clearly a piece. Missing, though, was bringing in HTML. Like, HTML was still an island. And it was Misha who had, I would call it, a brilliant insight, especially for a sidekick, to say, hey, what if HTML was just an alternate syntax for Lisp? Like, what if instead of a C-like macro language for templating, what if we just declared HTML to be a Lisp dialect and wrote whatever program we needed to make that possible? So in a nutshell, that's what Hoplon is. It's these two pieces, a data flow piece inspired by spreadsheets and FRP called the Javelin library, which does dynamic data flow, graph things. And then the templating piece is not really a templating piece at all. It's basically an HTML front end for the ClojureScript compiler. So when our designers think they're writing HTML in HAML or HTML syntax or whatever is in vogue, they're actually writing ClojureScript. And what they think are tags are actually function calls into the ClojureScript environment. So basically we've lined everything up with Lisp, turned HTML into a Lisp. We already had ClojureScript. So Hoplon is the environment that you get when you do those things. Any questions so far?
Do you want us to ask slightly technical questions at this point?
Sure.
Or until there's code up on the screen?
Yeah, why don't you? I mean, you can ask whatever you want. I'll get into code here after.
Okay, so there was one question that might be a good segue into showing some of the Javelin syntax. Wait, did I get that right? Is Javelin the Hoplon HTML syntax, or is Javelin
the HTML syntax it's not really a separate library. We call it HLisp for the semantic. Javelin is the data flow FRP piece. So for the HLisp,
how is that different than something like Hiccup in terms of what you can do with it and kind of the way that you use it?
That is a great question. So really the comparison there is between Hiccup and Lisp, the programming language, or ClojureScript, the programming language.
Mm-hmm.
Topically, they're very similar. They both have an evaluation semantic, where a ClojureScript expression will evaluate to a value, a Hiccup expression, which is going to be a vector with an operation form, which is a keyword, it's going to evaluate to a string. Now, one big difference between the two is that Hiccup, the templating language, everything always evaluates to a string. So you can't evaluate something and get a new value that's not a string and pass it to another evaluator. So I know, at least Dan, you said you were familiar with SICP or working through it.
That's right.
One of the so in that book, which is awesome, they build a series of scheme interpreters.
Right.
And one property of the interpreter is that it supports what they call the technical term I think is operational semantics. But basically the rules of the language are such that everything evaluates to a value, and you can feed the value into different contexts through the program. This transmission of values through the program is mediated by your naming system.
Right.
On Lisp, we have scopes and global definitions. Now already we've blown Hiccup out of the water because you can't define anything in Hiccup. Hiccup can only ever evaluate to a string. So like if you have HTML represented as Hiccup and you emit a string, you can't pass it to another function expecting a fragment of Hiccup. It needs to reparse it. So now you've got another sort of pre-processing phase involved.
To be fair, like with Hiccup, you don't really evaluate it to a string usually until you're rendering, right? So you can have a bunch of Hiccup functions and they're composable, and you work with your data structures on the final step, just say, okay, render whatever you have, right?
Yeah, I mean you can line things up that way, and probably the best. I mean, are you thinking of React, or excuse me, Reagent?
Well, Reagent was going to segue into that, right? Because that really has components, right? And they're obviously composable, and making the component can do whatever it wants internally, and just install put something other component to use, right?
Yeah. So I mean, there are a couple thought experiments there. One is one thing that you can do in Lisp is functions can return functions, and functions can return closures that are values that are closed over another thing. Now, a Hiccup expression, I mean, there isn't like a let in Hiccup. You're only ever going to get a vector from a Hiccup producing function, which means that markup is never going to be able to close over any values in the function that produced it, which is not bad. I mean, that's just a property of Hiccup.
A property of HLisp that you find yourself using frequently?
Yeah, I mean, it's as much as I use the let expression in Lisp. I mean, writing HLisp is writing ClojureScript. So actually, maybe I will get into code here, and I can pass around the Kool-Aid here.
Right.
Okay. So I'm going to go for screen sharing, which worked last time, but is fickle. So let me know if it doesn't work. Oh boy. Do you guys see the recursive windows also? Very Lispy.
That's amazing.
Okay, so how is this font looking?
That looks good. Yeah.
Okay.
Can you guys read that in the back? Okay, we're good.
All right, great. So I'm going to go ahead and initialize a new Hoplon project and give you a sort of tour of the tooling, which is different than what you may have encountered. So I'm going to go into my projects directory. Now we have Lineagen template set up for creating Hoplon projects quickly. So I'll do like line new type of project Hoplon Clojure Toronto. That takes about 6 hours as we download everything in Maven. Okay. Go in here, and what that did is that created a little project for us here with a README stub, a build.boot, and a source directory. I'll go ahead and put this build.boot briefly. Is that visible?
It is, yeah.
Cool. So build is our build tool. I don't know if anyone, well, if you used ClojureScript, you've butt your head against a line CLJS build. Basically, about a year and a half ago, we decided we just had enough of it, and we made our own build tool. So it does everything Lineagen does and more, and it's kind of a separate topic of conversation, but in a nutshell, it's an alternative to Lineagen that we developed originally as part of Hoplon. So instead of a sort of declarative file, it's a Clojure program that defines tasks. And one of those tasks, the one we'll be using, is development task. You can see defined here. And tasks compose in boot using function composition. So boot actually, and this is kind of a win for boot to discover that it works sort of the way transducers work in terms of how the middlewares line up. So these tasks in boot are like middlewares / transducers, and basically when you're making a new Hoplon project, you'll use boot to define your tasks. On the project I'm working on for work now, we have tasks for like deploying to Beanstalk and running test builds and running integration builds, and proven a pretty robust tool. Anyway, Our project scaffold is done, so now we can actually start up the ClojureScript compilation. So I'm going to do boot development. And the command line arguments that boot takes are informed by those tasks that we had in our build.boot file. So I had a development task defined, and now this boot development command will kick it off. This, again, will take another 12 hours as we start our JVM. Cool.
Does anyone have questions? So I'm sensing a theme here about converting everything over into Lisp.
Yeah, we have an informal motto, which is Lisp can do it. Basically, you know, my feeling is that all of our field has been painted by things that aren't Lisp. You know, McCarthy made fun of XML for not being Lisp, and sort of it's a theme to just sort of, you know, call it like you see it. I don't know. I mean, Lisp is a really I mean, we're most used to Lisp as represented by Clojure and ClojureScript, but I'm sure, you know, those of us who have dabbled in Clojure have run across Theme or other Lisps, and I don't know. I'm learning new stuff continually about Lisp and have been for the past like 6 years, and I don't know. Yeah, Lisp can do it. Like, it can do it. Just believe. So our server started here. This started like an embedded Jetty. It's listening on port 8000, and then this output here is just telling us how long the last ClojureScript compilation took and time elapsed since the last successful compilation. So this is part of the boot ClojureScript tooling that we're looking at now. So now in our browser, we can go over to localhost 8000 and hopefully see a message. Close these things. So let's go back into Emacs and take a look at the code that's generating that. So here is the ClojureScript source code behind this page we're seeing over in the browser. Now, this is definitely not the world's most complex web application, but it demonstrates half of Hoplon, which is the HLisp stuff. So the first big difference between this and a normal ClojureScript file is this page declaration. You know, at the top of a ClojureScript namespace, you usually see the NF declaration, which names the package that the rest of the top-level forms in the file should end up in. And one thing we realized is that for web apps, you kind of need a different thing, because you need a way to define the artifact that you're deploying, the thing that represents the application, the thing the user will interact with. When you're doing Clojure on the JVM, you'll usually set up like a main method, which is your sort of, we call it the sort of crude, but the in-hole, the place where things begin. In Hoplon, the place where things begin are these pages, and this page expression, I guess it's a special form, or excuse me, a macro, takes the name of the page to generate, so it generated index.html, and, you know, libraries to refer in, just like an NS thing.
Is there always a one-to-one relationship between a page and an HTML file?
Yes.
So does HTML get generated because of the lines, and you just create a word for it dynamically, or?
Could you repeat that? I'm sorry.
Does HTML, like, it's running in ClojureScript, right? So it generates in the browser and just creates a dynamic word?
Yes. Yeah, if we go back to our build.boot file, we can see what it's doing. So there are two tasks, and this is the, there are two tasks, well, 3 tasks being composed. First, we're saying run a dev server. That's what started Jetty. Then we're saying call the Hoplon task. What the Hoplon task does is it converts these cljs.hl files into ClojureScript. And once that phase is completed, then those ClojureScript files are compiled by the ClojureScript compiler into JavaScript. Does that answer your questions?
Kind of. So where does the binding of the page happen, right? So like when you go to index.html, Presumably that's generated mindset, right?
Oh, yes, yes. So what happens here is Hoplon, the first thing it does, well, we can look at the markup. Let's actually use the inspector. This is probably not going to be super easy to see. If you look at the structure of this page, we've got an H1 with, that's the call to our H1 function. And then I think this is inserted by a Chrome plugin I have going. But this content did not exist when the page loaded. What happened was the first thing that Hoplon does when the page loads is it blows away the DOM that was created by the static HTML in the page, and basically removing the body and appending the return value of this page file here. So you notice the last expression that shows up in the index file is this call to HTML. And what Hoplon does is it takes that value, which by the time this is running is an actual HTML live element in memory, and replaces the body of the page with that value.
And how is the routing handled?
How is what?
The routing handled.
There are a bunch of ways to do it. You can use something like secretary if you want to go that route. We tend to do something slightly simpler, which is we use a cell to contain the current route, and you can dispatch on that.
Okay.
The one thing we have tended to avoid is push state, the sort of latest and greatest browser API for doing this, because we found it makes things even more complicated. But yeah, before I go on, I should show people, in case you haven't, this Discourse site we have. I'm a huge fan of Discourse. I was honestly skeptical of it, but we have a lot of questions and answers about things like routing, how to do routing. People share their approaches. In general, we have a pretty cordial community. So if you do have questions that I can't get to or answer poorly, I encourage you to go to this place.
Nice. Did you post a link to that in the meetup already?
There is a link to it from hoplon.io, but I'll keep that open and add a link to it.
Great, thank you.
Yep. Okay, so any other questions so far?
I'm just kind of curious, like, if the Lisp stuff is it sounds like it's kind of a preprocessor. Is it a preprocessor, or is it like, how does it fit in with the compilation?
So there are two pieces to it. There's kind of the idea, and then there's the tooling. The tooling is definitely, it's a program that parses HTML or ClojureScript and emits ClojureScript. The concept is a set of more or less well-defined semantics that Misha mapped to HTML that define concretely the meaning of a particular HTML expression once you convert it to ClojureScript. So that tooling is part of Hoplon proper and is being run by boot currently.
And the evaluation is happening client-side using the ClojureScript runtime.
Correct.
So this file ends up getting converted to regular ClojureScript, which then ends up running in the browser.
Exactly.
Okay.
Yep. And the final thing to note, I guess, well, hopefully we'll keep noting interesting things, but one thing to note at this point is that these calls to these functions, like the body function or the h1 function, they return values, and the values they return are not strings. The values they return are live DOM nodes. So the advantage of that versus returning a string or a hiccup vector is that you can pass these things to like jQuery plugins or other JavaScript libraries, and they'll be able to work with them as if they were nodes. So this has been pretty useful. This has helped me just the other day use a gauge library for JavaScript. Any other questions before I proceed?
Yeah. So when you connect, do you connect to Emacs? Can you basically do live REPL evaluation from there? I guess I have it.
Yeah. So it's not really a REPL. We haven't really settled on a name. Basically, let me get it going here. It's just application reloading. So we don't have a REPL per se, but I'll work on the application down here and save the file, and we have a little watcher that will reload the page.
But if you build up state in the client, then you're gonna do load away when you reload.
Yes.
Okay.
But you can. There are other ways you can save the state between reloads. Like you can hide it in the was it local storage?
Mm-hmm.
Or you can, have a function that runs when the page loads that loads up your seed data.
Okay. I mean, that's one of those things I like. For example, if you use like big wheel or light table or something, right? You can actually just connect RAPL to browser, and then you don't.
Yeah.
Load.
Yeah, I think that's maybe one big philosophical difference between everything Hoplon and tooling and light table and other REPL-oriented things is we're more oriented towards building applications and not really experimentation. I mean, not to say that there isn't value in both things, or particularly in experimentation, but...
Well, I find like RAPL, right, like it's not really experimentation. Let's say you build, like, that's how you build applications. You do it in practice, right? You can build a state on time. It's not really kind of like selling cloud.
Yeah, I don't know. I don't know what to tell you other than I did that for a long time and I just don't like to do it anymore.
Alright, well, that's fair.
So, can you show the original source of the page when the page loads? So not from the spec, but actually what Chrome gets on the first load?
Yes, actually, we can do that by turning off JavaScript.
Right.
And let me see if I can remember how to do that.
You can just do a page start extension.
You should first command U. I think.
Let me. That sort of worked.
Nice. Okay, so you search just like one custom JS. Nice.
Most of my skill is Googling. So that is what it looks like. That was a great question. So the first thing that happens here is we're defining this CSS file to this GUID named CSS file. Basically, for any one Hoplon application, we claim ownership of two files on the class path: a CSS file and a JS file. They're both named after this this UUID, and that's so that we don't conflict with other things on the class path, or at least we hope not to. So the first thing we do is define that, and then the second thing we do is bring in a JavaScript file, and this is sort of like the bootloader for the dynamic piece. And then finally, this Hoplon init function is called, and that's the function that blows away this body and replaces it with the value that we got from running the JavaScript. Interestingly, we have a. This is a pretty important piece. I can set pre-render true. So one of the things that'll come up when you're building apps like this is the fully dynamic thing doesn't always fly. And like Misha is building an application that's a hostel booking website. And oops. And it's actually important that various places within the app are accessible by the Google Spider. And Google is getting better at surfing JavaScript and stuff, but you still want to be able to control what spiders see. So pre-rendering is an important piece, and we support that fairly crudely by shelling out to Phantom.js at build time, which is what we'll see it do here.
Rhino or something.
I'm sorry?
Out of curiosity, why don't you go with something like Rhino rather than just JVM?
Yeah, we could totally do that. And also Nashorn, in Java 8, they even have a JavaScript thing built into the
Any plans
I'm sorry?
Any plans to move to that, or is there like a reason you're doing this with the shell out?
We just haven't had any problems with the current thing, and it's a very small amount of code, so we could probably, it would just be whatever we need to do to learn how to call a JavaScript with Nashorn would be the change. So I would gladly accept that contribution. So now if we go back to curl, we should see kind of a different story here. I got it from curl. I'll type it into this little handy freeformatter.com for all my formatting needs. And we'll see what this looks like. Of course, actually, that one we could look at here. Oh no, it gets blown away too. So there we go. There is the page that's generated by the pre-renderer pass. So it can be spidered.
Nice.
Everybody cool so far?
Yeah.
Okay, so I think we're ready now to do more things. So I just wanted to give you all a flavor of components and some of the affordances of working in Lisp as opposed to Hiccup or something else. So, you know, the way we tend to build Clojure programs is by writing functions, and we build them up, typically bottom up or you know, top down. You know, it depends which way to read your Clojure file, but you're definitely going to have functions, and they build on each other in some direction. So one small example of what you can do with HLisp is a little function called QuickList. And let's say QuickList is a function that takes some number of items, and we want it to return an unordered list, and we want each of the items to be a list item. Now down here in our body, I'm going to say QuickList 1, 2, 3, and I'll save that. Any luck, that gets reloaded. Oops. One second. Pardon me, I'm going to go ahead and disable pre-render. I think it's doing something up. So yeah, the idea here is that, you know, since Lisp, you know, Lisp can do it. We know that DOM nodes, or the DOM node constructors, which are the HTML literals that we use to build up web pages, if we just view those as functions, we line those two ideas up, then we have this ability to create custom elements. So here we've got basically a custom element quick list that takes these strings. I think, actually, the reason it was showing weird stuff is because I needed to map stir over those numbers to turn them into text nodes, or turn them into strings. But, you know, we could put other stuff here, and it should update appropriately. And of course, this being Clojure, we can do awesome stuff, like, you know, do sequence stuff. That didn't work. That's because we need the awesome apply function.
Right.
So Lisp rules, guys. It just totally is awesome. You know, here's an HTML element that we just applied with children. Totally sweet. So that's kind of that's the premise. You know, tags are functions. You can make functions. When you make a function, you're kind of making a custom tag. Now, it's not always this simple, because we need to really line up with HTML. We need to be able to do attributes, and with the semantics that Misha created, we do have the ability to do attributes and also children. But he created a macro called deflm, which is just a convenient way of writing a component function that gets past an attribute map and a list of children. So we can kind of do the same thing here. Map li bids, and then put that in the UL. And then I'm just going to JS alert the adder map. Now, if we call QuickList with the attribute Toronto rules, because we know it rules. Are you guys affiliated with HackLab by any chance?
Bento Miso and HackLab share an understanding. But the Clojure meetup is not directly affiliated with HackLab.
I see. Yeah, I was just curious because I was in Toronto. I used to live in Rochester, which is just south of you.
Right.
And shot up there one weekend and visited Hack Lab and really had fun in Toronto.
Yeah, it's a very cool space. We'll have to have you here next time.
Yeah. Yeah. So what happened? I guess I was sort of walking and chewing gum at the same time, and so we have this call to this quick list function /component/HTML element, and we declared the Toronto rules. So when this element was created, it called JS alert with a pretty printed attribute map.
So if you want custom attributes on a built-in HTML element, like UL, for example,
Yep.
Do you need to define a custom element to map that correctly?
You can either use a custom element if you want if you're doing sort of fancy things, or you can just make a def on. Like here's a quick example might be. So let me bring in Bootstrap real quick. So these CSS frameworks like Bootstrap and Foundation, if you're familiar with them, they generally ship as a CSS file and a ton of conventions for using the classes that CSS contains. And this is another example of where Lisp would be awesome if we could somehow leverage it. Like this is stuff we want to automate somehow. We want to generate these class names. We want to create our own constructors for making things that conform to this framework without buying in necessarily to the author's way of doing it. So one thing that this is really useful for is wielding these CSS frameworks. So in the Hoplon repo, in Hoplon we have a vendor directory. In the vendor directory are a bunch of things that we package as Maven dependencies and push to Clojars, and one of those things is Bootstrap. One of the things that Hoplon comes with that like stock ClojureScript doesn't is we have conventions and idioms for packaging, fonts, images, all that stuff, and doing the right thing on the class path. So I can very quickly add Bootstrap to this app, which I'm going to do right now, without messing with preambles or any of the stuff that you do to configure stuff in with Linigan. Here, pop this in. Unfortunately, I do need to restart the thing because we're messing with the class path. But once this comes back up, I can show you an example of doing Bootstrap stuff. The other thing, I guess we haven't really touched on cells at all.
Right.
So I may do a quick Bootstrap thing, and then we'll move right into cells unless anyone has. I mean, I'm at your command. So whatever you guys want to know, just let me know.
Yeah, that sounds like a good flow.
Okay. All right. So if we reload this, it should look cooler. Still not going to win any awards. But hey, it's using a trendy font, so that's good. So I forget exactly. Does anybody know offhand like the class that stuff in Bootstrap needs to be, or like? Oh, geez. Getting started. It's funny. I've been working in Bootstrap for the past like 2 days, and I have no idea how it works still.
Right.
Examples. You know what I think Bootstrap has is a button. Yeah. We could use a button. So let's look at the markup for this. Okay, so the class is button. Button type button, class button. Let's make one of those in our app. Doesn't look particularly themed. btn large. Let's just copy the classes from this. Sort of better. So, here's an example of a thing that we may have a lot of these buttons in our app. Make a lot of them here.
So named parameters are named arguments, I guess, in this case. become attributes for the DOM element?
Correct. So the equivalent HTML for this button would be, button. I'm typing butno, which is a very strange word.
And if we give multiple unnamed arguments, those all become children.
Exactly. So what we have here is there's some fanciness in our evaluator, where we know that a keyword can't be a child.
Right.
And that's how we know where the children start and where the attributes end. So yeah.
And they have to go all the attributes first and then all the children. You can't mix them.
Exactly.
Okay.
So what I'm going to do is I'm going to do something a little different. So we know that we have, let's say these big buttons show up all over our app, and we're tired of pasting this class in, and we can't, we need the tools of abstraction. We need the power of Lisp to solve this problem. But one thing we can do in our app is start to build up a little library of custom elements that we use in this app, and that we might later be able to use in other apps based on Bootstrap. So I'm going to make a function called helpers. .cljs.hl, and this time I'm going to use the namespace thing, because this is going to be a library. This is going to be library code that doesn't necessarily emit HTML. And then I'm going to make a def element called big button that takes attributes and children. And this is going to return a button. It's going to return one of the buttons like we need. Another thing to note about the HLisp evaluation semantic is that if the first argument after the attributes is a sequence, that sequence gets spliced in as children. So, saying this is the same as saying this.
In this example, sorry, you have like the attrs you can pass in. Can you mix the ones you pass in with the ones you already predefined?
Sure. So, in addition to taking key value pairs, this thing can take a map as the attribute map, and it'll do the right thing.
Okay.
We can do like merge, our thing and things like that. So I guess we definitely want our button configuration thing to win, so we'll put the adders that came in first. Go ahead and save that. Now over in our page, can everybody still see the font on the Emacs?
Yep.
Okay. So over here, I'm going to require helpers refer big button. And then I'm going to kill my I think this will actually not work because we create a new... Oh, no, it did work. Will it work? Too soon.
Nice.
So, yeah, we made a button. But this is actually a good segue into Javelin here, because the beginning of any reactive application is a button of some kind.
Right.
Now we have our button to work with. So let me first do a... So the first place to start, I guess, with a reactive web app is the counter. So in Hoplon to manage state, we have primitives. I say primitives, but they're a type, in particular ClojureScript reference type. They satisfy the same protocols as atoms. And they're called cells, and they're provided by this ClojureScript library called Javelin, which I think I've given talks on. I have given talks on separately, and you can actually use Javelin without Hoplon. It's totally separate ClojureScript library that's totally usable through Lineagen or whatever, and it looks like this if you use it outside of Hoplon. In Hoplon though, we always include it, and we do all the referring and stuff automatically. So one of the liberties we take as framework authors is we do all kinds of, easy is better type stuff that is very anti-closure, but this works. So in this page, we have the ability to create an input cell of 0, and I'll just alert that.
There was a common Lisp library from a few years back called cells, I think.
Yeah, there's this awesome character in the Common Lisp community, Kenny Tilton, and about 10 years ago, he released a library called Cells for Common Lisp, and it's also a spreadsheet-inspired reactive thing.
Mm-hmm.
I would say that, I mean, if you all have been discussing FRP, you're probably hot on behaviors/signals and event streams.
Right.
The big difference between FRP and cells is that there are no event streams. There's only signals. So in a way, Javelin is kind of like FRP without the event stream. And I think one thing that's been interesting to watch Elm do over the past year is move also towards a sort of signal focus. So
everything is a signal.
Yeah. The trick with everything as a signal is that if your propagation semantic is a value-based, the way a spreadsheet is or the way FRP signals are, then you can simulate event streams as long as you put distinct values in your signals. So the classic way to do that is you put a timestamp in a signal, and boom, you've got an event stream.
Right. So your value is a compound value of the actual value of the timestamp.
Exactly. So you put like a tuple of timestamp value in a signal, and now you've got an event stream. And to unbox the event stream, you just pull the second element of the tuple.
Right.
Yeah, it's definitely a weird thing when you're first coming to Elm. Having the notion of repeated events with the same value, and just like how sometimes you want to get it at that notion of an updated value, but you have to kind of find out about it kind of in a roundabout way.
Yeah. And Misha and I sort of ran into that the hard way, and actually this sort of harkens back to the initial points about building up state. One of the reasons I think I was initially attracted to the idea of preserving state between application reloads is because if you're working with event streams or something similar, there's a temporal axis, which is the events that have happened, that is never represented anywhere as data. And once you're in a world where things exist that aren't represented as data, they're very hard to reproduce. So another attempt at to solve this problem that I was involved in was this thing, Pedestal app from Relevance. And I was less involved, but basically Brenton would just call me over to his desk and I would watch the awesome stuff that he was doing.
Right.
But a lot of the Pedestal app stuff was also tooling for managing event streams. And so it's hard. I don't think we may have just cheated in Javelin, and Elm might be cheating too by just saying there are only signals, but definitely found it's really nice way to work, particularly because there's always data behind an interface. You can't display something that's not data in an interface. So anyway, enough rhetoric. Let us compute. So yeah, we've got the cell thing, and this is like the Atom constructor, except it just returns a cell. So I'm going to say def counter is going to be a cell with a value 0 in it, and let's down here in the button constructor, I'm going to put the value of the cell in as a child, and that's not going to work. But I can make a form. That doesn't work because this is a number, and I think the number is getting read by. This is weird JavaScript stuff happening. But I can say counter as string, and let's make that a formula cell of counter.
So we encountered this earlier when we were displaying a list of numbers?
Yes, we did. Yes, we did.
What's the underlying issue? It's not becoming a text node in the DOM?
Let's look. So I think that is the issue. If I do like JS alert number, we should see it. if I do JS alert of like h1, then we get the inner HTML with that. Yeah, this might be a Hoplon bug too, because I don't remember running into this problem recently. But yeah, basically we just need to coerce the thing through a string before we make it a child of an HTML. So the way we can do that is, in addition to the cell function, there's a macro in Javelin called cell equal, and it is the formula constructor macro. So it takes an arbitrary expression and like this, for instance. And what it does is this expression is run in response to changes in dependent cells. So that basically we know this will run whenever the value of counter changes.
We don't have to do it now, but there was actually a request earlier to look at the insides of that macro.
Yeah, there's actually not much to it. So Javelin is about, I think, 200 lines of code. There's really not much. Most of the ideas were lifted from Flapjacks, but yeah, it's similar in spirit to like the core async SSA macro. Code walking, another awesome thing you can do in Lisp.
Right.
So we can use the cell equal thing down here, and we want this to be the string of counter. We're already seeing, I think, one of the benefits of this kind of programming with values is that we don't yet have any callbacks, but we're also not writing. You know what? I'll just withhold. It's easy to babble forever about this stuff. I think I'll just keep coding, and maybe you can get excited about it that way. So this is great. We have this counter, and but it's not changing. So one thing we can do is say with interval 500 milliseconds swap counter inc. With interval is a Hoplon convenience macro that sets up a JavaScript set interval, basically. It takes a milliseconds and a body. And what we see here happening is our input cell, counter, is being mutated. That's causing the body of our formula cell to get run, which in turn is modifying the contents of the big button element. So that's cool and stuff, but what we really want is for the button to do stuff.
I think there was a question.
No, I was just going to okay.
Okay.
Okay, so I'll continue on. So our buttons here, and in fact all the elements that you can work with in Hoplon support all of the jQuery events, like click. So click is going to be an attribute that takes a function. You can see in action here. And we can do that with any element. Basically, there's a multi method inside Hoplon that is configured or recognizes these events, and we can disambiguate event callbacks like this from normal attributes, because you'd never set an HTML attribute to be a function value, and you can't. It's always a string. So Hoplon, the Hoplon HLisp tooling knows that when it encounters one of these attribute function pairs, that's definitely a callback. So now that we have this callback wired up, the thing we want to do is swap on our counter. We'll do swap counter inc, and now we're counting up. So immediately, the thing to point out about this is that this is an architecture that people would call unidirectional data flow. The event comes in to this button element. It's handled by jQuery's event management thing. We have a function that we want to call, a callback to happen when that event happens, and we convert the fact that that event happened into data as quickly as possible. So the data we're storing is count, and we're not, storing number of clicks necessarily. We're storing this counter because other things might cause the counter to change. So, we can have with interval 500. might have data coming in from multiple places. Typically, the two places where data will come, well, really the only two places that data will come in to an app like this is from the server and from the user. So it's not always the case that data from both places will go into the same cell, but it's certainly something that can happen.
Could you talk just briefly about the re-rendering strategy? When counter that cell gets updated.
Yes.
Yeah.
Let me see if I can. So there's another link I'll post. There's this document, the Cells Manifesto. It exists on Blogger, so it's from like the Stone Age.
Right.
But it's Kenny Tilton's semi-rants about what cells are and how they work and the value he sees in them.
Right.
And his system is much different than Javelin, but he gets down to implementation of data flow. The two things about data flow, one is the fact that propagation is only ever on value. And the kind of thought experiment I use to describe this is like when you're working with a spreadsheet and you change the value in a cell, you can't write a formula that does something when the value is, like say you have a cell with 5 in it, and you go in, you double click, you back it out, and you type 5 again. As far as any of the formulas in the spreadsheet know, the value has always been 5 because while you made an effort to change it, you didn't change its value. Javelin is the same way. Everything is value-based. This is one of the reasons why ClojureScript, this is maybe my favorite thing about ClojureScript, hands down, is the fact that it has a freaking awesome, or just an intuitive sense of equality. This is something that's like really maybe why JavaScript is, maybe the heart of why JavaScript is so difficult to work with is because the equality rules are so confounding. But in ClojureScript, we have a really sane sense of equality, particularly between collections, between basically everything, does what you would expect. So that makes equality a sound thing for us to work with from a data flow perspective. So value-based propagation is sort of tenet 1 of Javelin. Tenet 2 is that changes are propagated in dependency order. So this is the thing that was it James with the Elm library? So probably, I imagine that you're doing, the linearization of the signal dependencies, because it's important for the FRP semantic that the formulas are run in dependency order. So we do the same exact thing in Javelin. It's important when you're building these data flow systems that dependencies run in the correct order. If you don't do this, you can run into really complicated consistency bugs where things are showing or not showing in your UI and you're not exactly sure. But you can fix it by changing the order that you do stuff.
Right.
And randomly changing the order you do stuff is not a good way to program in general. I mean, it'll get you there, but you don't want to really do that all the time. So
in your case, the dependencies are both formula cells and also any HTML elements that rely on the value cell or a formula cell?
So the HTML elements are sort of transitive dependencies of the cell graph. So basically, the edges of this cell graph we consider to be sort of outholds of the places where events leave the graph, or data leaves the graph to enter the DOM or elsewhere for effect. So what's happening here is our elements, when they see a cell child, they wire themselves up to that cell child in whatever way makes sense. So in this case, it's saying, oh, you passed me a cell, I'll attach a watcher to that cell and change my internal value whenever the value of the cell changes.
Okay.
So like atoms, our cells implement iWatchable and directly.
Could that ever force a parent element to re-render as well?
No, it's unidirectional strictly. So you can have input cells and you can have formula cells, but nothing you can do in a formula cell would cause propagation to happen short of calling swap within a formula cell, which we don't prevent you from doing. And actually, there are some cases where you may want to do this, but you'll know because that will introduce a cycle basically. If you have your cells formula cells
form a DAG, is that true? They have to.
Mm-hmm.
So you can't have that effect like you do in Excel where the formulas reference each other and you can feedback propagation going through the system?
You can. You can. I mean, it's actually really hard to do that in Javelin because inside formulas, cells are automatically dereferenced. So it's hard to get at cell values inside our formula expressions. And that's just proven to be a very rare thing to need to do, but it is possible.
It's probably good that it's hard.
Yeah. Well, you'll know when this has happened to you because your browser will just immediately beach ball, and then you're done. Time to have some scotch.
And within the DOM rendering tree, there's no way that re-rendering big button can force its like DOM element parents to re-render. Is that true?
That is true.
Okay.
I mean, unless I mean, it's when you're talking about the element, I assume you're meaning events going into the element.
So big button re-renders every time the counter cell updates its value.
It doesn't actually. I mean, it doesn't re-render. What it's doing is it's calling set inner HTML on itself.
Okay.
Yeah. So we're not looking at a total screen repaint here. We're just looking at a single element that's changing its inner text.
Mm-hmm.
And actually, it's, we can look at it do that. It's kind of interesting.
Right.
How are we doing so far? On time and questions and anxiety?
We're good. This has been great. We've got another 20 minutes.
Okay. So there are definitely things I could show, but before I do, any other questions?
Just a bit going back to like events, right, the relations. So like, how do you handle cases because it is a DAG, right? So you have like two elements, say, on the same level, right? Or one element might attack something at a different level. Like for example, like I have cases, right? You have like a big form, and you have like, if you select male, you get one set of questions. If you select female, right, you get like different set of questions.
Yeah.
And like combinations happening because you selected this values, you have to update this value and so on.
Right.
So in your structure, is it required all to be part of like a tree structure, and you can only propagate events going forward?
Could you repeat that last sentence, please?
So the events, like in your structure, the events, it sounds like they propagate from parents to children, right? But then you have like two elements in a tree at different parents' nodes. Can they communicate with each other easily?
Yeah, so all communication between elements is going to be mediated by cells. So
Okay.
whether or
So
not...
I like channels, I guess, in person, right?
They're not channels. I mean, I'm hesitant to call them channels because they're definitely not core async channels. They're not queues in any way.
Well, it's a similar idea of it's a sync point, right, for two elements that don't have to know about each other, but they use a cell to communicate.
Correct. And actually, I can show a quick example of that kind of dependency. Before I do, I guess I have an anecdote. So, like the data consistency problem. So in data flow literature, this problem of dependency order of signals, if you get it wrong, they call it a glitch. And I guess that's because the data flow has its foundations in like signal processing and sort of analog real-time stuff.
Right.
So one of the glitches that Misha ran into when we were working on, so we were writing a form for the Fresh Diet, which is a company that we both used to work for, and we were a meal delivery company, and we needed new customers, to fill out a form with basic information about themselves and information relating to their diet and physical disposition and tastes and things like that. And there was one part of the form which was, it asked your sex and whether or not you were pregnant. Now, of course, it makes no sense to ask a male if they're pregnant. I mean, there was that one movie with Danny DeVito, but I'm pretty sure it wasn't a documentary, and Arnold Schwarzenegger. But we had this situation where we wanted to make sure it was impossible for the person to mark themselves as pregnant if they were male. And if they were female, then we didn't need, we still needed to show that box. And if they were pregnant, then we knew they were female. So it's like, how can we architect this form so that it's never possible for somebody to say they're male and pregnant, and we save them some clicking, if they're tactical in what they click on the page. And no matter how we did it, we always ended up with situations where we'd like reload it fast, or use tab to cycle through the inputs, and manage to click on male and pregnant at the same time. And that's kind of how we mutually discovered this notion of consistency, and saw how form data can be related in these interesting ways. So I can give you a quick example. not so that metric, when we were building Hoplon or building Javelin, we came to call it the pregnancy test because it's a test of this consistency variant. So let me share my screen again.
We can see your screen.
Okay. Prepare for recursion. All right, so we'll.
Yeah.
So our little counter is happily humming over here. Let's make this a little more interesting. So there's basically one piece of state in the program right now, which is this cell with the number 0 in it. And we do have a formula cell down here, but it doesn't really count as independent state because it's derived directly from other places. So we can sort of keep hanging formulas off of this state in the form of formula cells. So I'm going to make another element here, which is going to be a paragraph, and it's going to say the number is given. Now, unfortunately, this thing displays no matter what the number is. So we support one of the jQuery directives that we support is something called toggle, which is an attribute that takes a cell that reloads. Now we've established a relationship between these two HTML elements through the cell that they're both aware of, this counter cell. So we can basically, if you want to do something like a wizard, where you have, or like an accordion-style form, where you've got chunks of the page that depend on the data of some previous section having been completed appropriately, or matching some constraint like one does all the time. And this is kind of how you would do it. You'd basically set up a cell to hold the state of the form. Then you'd have formulas that would check whether or not the form was valid. And then you could attach HTML elements to show or hide depending on the state of your state machine. One of the interesting things about this is that, well, here we have our formula cells baked into the markup, but we could just as easily lift those up to the top level. Now I've got a formula cell called counter even, and this is a good place actually to show up some of the macros that come with Javelin. So we have defc, which is shorthand for def cell counter, and then we have defc equals, which is shorthand for counter creating a formula cell.
Mm-hmm.
So now we can go down here and we can say toggle counter even.
Can a value cell hold a function as its value?
Yep. Yeah, you can put any value you want inside the cell, including HTML elements or other cells or functions or anything.
Okay.
So now we have the same behavior, and actually this, if we do one more thing here, sure this works. So what we've done here is we've lifted out our input cells, our formula cells, and our inputs, or our, I'm not sure what I call them, maybe procedures, above the markup. So together these constitute, what you might think of as the state machine API. And then down here we have the markup. The markup doesn't contain any logic really, other than some formatting information. And this is really our response to this initial problem of how do you separate how something works from the way it looks. Because what we're able to do now is put these two cells in a single function in a separate library or namespace in this project. And now any designer who can write HTML and knows about attributes and can make sense of these and know that they can be wired to elements with jQuery and implement this API and markup without needing to necessarily program and close the script. So this is kind of mission accomplished, I guess. Unfortunately, I was laid off from that job before we got time to like fully realize the vision. But they were gracious enough to let me open source all this stuff, which is I'm really, really grateful for them for that. So,
Nice.
So this is kind of the dream realized. You'll notice it's all Lisp. Any other? Well, let's see. Any questions about any of that?
Yeah. So, what if like I wanted to use a conditional instead? So right now you're using jQuery to toggle the display of the logic, right? So you basically call jQuery toggle and you hide the element when the function is true, right? But because you are in Clojure, like you can technically put an if there, right? Like a normal if statement within like your DOM definition, basically, right? So the Ace list, like, can you actually just like use an if there and do what you do in like, for example, reagent actually, and just like actually toggle for real, like move around the DOM when something is set or not?
Do you mean like?
So saying if counter even.
Yeah,
key.
exactly. Basically, add and toggle the different pieces of the DOM dynamically, but they will not be like childs of a cell, right? It will just like be the DOM will change depending on the value of the cell, right?
So if you run basically the P statement,
Yeah,
right?
exactly.
So
Kind
if
of.
counter even P, follow that.
I'm sorry, I don't really follow. I'm not especially familiar with reagent.
So just in your example where it says P toggle counter even,
Yeah.
if instead you had like if counter even, then P with numbers even, and then otherwise something else. Like the question is,
Well,
can you
empty, right?
can you put an if statement based on a cell straight in the HTML, and do it that way?
I'm not entirely sure, but we can try.
So you have to do this. So the cell equals there. You end up. Okay, I see. So
That was my question, basically. Like you need to surround it with a cell, with
Okay.
a formula, in order to
Yeah,
render.
So the answer is no.
So basically any dynamic portion of the DOM needs to be in a cell equals. Is that right?
Yes, basically. And actually, this is a great question because it touches on one of the minor improvements that we have planned for the next version of Hoplon. So more or less, the things that React and that does and the things that we're doing here are allocation schemes. If you've done C programming, you've used free and malloc, and if you've done Java, or Clojure, you use garbage collection. But basically, the DOM is a kind of heap, and the value add of tools like Hoplon or Javelin or Reagent is they're like the GC to the DOM's heap. They give us a level of automatic management of the DOM, and the reason we need that is because you can't actually have serious, your application cannot work if you do, for instance, create a lot of DOM nodes and never attach them, or attach a lot of DOM nodes and remove them in one big sweep or something. So the allocation strategy that we do is, it was born of our intuition with Javelin and from what we knew about cells and FRP. And one of the things we came to realize as we wrote more Hoplon applications is that really we want cells and elements to be interchangeable also, because and I know he's the gentleman, the very small person in the middle of my screen behind Dan, who asked a great question. Can you put a cell anywhere you can put an element? And the answer currently is no. But in the next version of Hoplon, we're lining those two things up so that you will be able to put cells wherever elements could go, or vice versa. And they would behave interchangeably. And then that sort of completes the allocation vision for Hoplon. And I think, honestly, it was a great question from you because I think it validates what we've been thinking about what's intuitive and what's not.
Right.
So,
Right.
so the answer now is no, it doesn't work, but it will.
Nice.
How does Hoplon deal with animation?
So you can do anything the browser can do. Actually, I think I have. the missile command thing. Happened to it. I might have. I think I put it on Twitter. Twitter is like my memory. Oh no. I don't remember. But basically, the way I've done animation is with SVG. So in the same way that HTML can become a Lisp if you line up the semantics, all the SVG tags can become Lisp functions as well. So what we do, actually in the Hoplon, that we have a Hoplon SVG namespace, which, oops. Let me see if I can find that. Oh, it's craziness. Yeah, in source, Hoplon, SVG. Basically, we have Clojure script functions that will generate all of the that will evaluate all these SVG functions, and you can use them the same way you do HTML. So basically, that's probably the way I would do animation, just because if you use SVG, you get hardware graphics support.
Right.
What if you want to use CSS animation? I'm coming from Angular, and I know that they've spent a lot of man-hours fixing their animation.
Well, I'm sorry.
Has problems with CSS animation.
Oh, CSS. So CSS animations are the final frontier for us. Actually, there is, and CSS in general is kind of an unsolved problem, as far as I'm concerned. We're concerned. There is a thing recently that came out called the Grid, which is a constraint solver-based CSS positioning framework that holds promise. Probably something you haven't heard of is the thread we have on our discourse site, where trying to find where it is.
Are you guys thinking of integrating the grid?
Well, so the thing about constraint solvers that is weird from a software perspective is, a constraint solver takes inputs and returns a solution, and the solution is then what gets displayed. So like if I tell the layout system, I want this thing to be on the left, and then I want this thing to be on the right, but at some point in the application's lifetime, these two things I asked to be positioned are sized such that they can't be left and right. Maybe they need to stack. And the constraint solver will make a decision for me and based on some heuristic, rearrange them. And this is another one of those places where I'm really skeptical of software that leans on heuristics to accomplish things, because that means it's not deterministic.
Yeah,
that's sort of the heart of my skepticism. But it could be amazing. I haven't used it extensively.
Right. So you mentioned that there were two sources of input to kind of your Javelin system. One was user input, and the other is input from the server?
Yeah.
How do you keep those two in sync?
It's a great question. The strategy you use there is going to depend on the kind of application you use. For instance, if you're building an application like say you're a bank, your users don't see each other. As far as they're concerned, the application is their slice of the database. So the kinds of things you show them are don't need to be synced up with other people, what other people are doing. You're more interested in the consistency of that one person's data. Now, if you're writing a multiplayer game, now you're really interested in coordinating users and latency. So maybe you're interested in doing push or things like that. So I think initially when we released Hoplon, I advocated a particular kind of architecture that's called CQRS, as the kind of, and I'd still recommend it as a good default, but really I think the answer here just depends very heavily on what you're building. I can share a diagram. So I think in my experience, and at least as far as the things that I do for work, by and large, I'm writing applications where users are, basically CRUD, fancy CRUD applications. And I think CQRS is a better answer there than or a better default anyway than MVC in a lot of cases. So I have a diagram kind of illustrating perspective. Let me just pull it up here one second.
CQRS, command query responsibilities. So yeah, in the talk that you gave, I guess it was a while back now, and also in the architectural diagram on Hoplon.io, it almost looks like when you push data from the server to the client, you're pushing all of the relevant data every time, instead of doing it in small pieces that have changed.
Yeah. It can or it can't be. I don't know. Like I said, I think I was a little too paternalistic in architecture, just because that's what's worked for me. The problem with pushing diffs around, and this is like a general distributed systems problem, is that if you're dealing in differences or deltas, both sender and receiver need to agree on some basis. And agreeing on that basis is, an active area of research in our field, and really hard to do. So, I think the best default is when you can get away with it, push full values around, because a value needs no context, and whatever context it needs, the code that's running on the server and the code that's running in the browser can provide through evaluation and interpretation of that value.
Does the full value correlate to the contents of a single cell, or is it multiple cells?
It can. So in the menu selector application, which is like the first Hoplon application for the previous company, in that case we were able to get away with just every customer had their own cell, basically, and that cell was basically their view into their piece of the database, their piece of our application, and we were able to get away with that because our customers were didn't know anything about each other, and we totally controlled. Basically, it was like an application for a single user, as far as they were concerned.
So whenever the user sent data to the server, you would send back their full cell every time.
Correct. Yep. There was one optimization which actually two optimizations fell out of that. The first optimization was we separated like catalog data from user data. So we had two cells, and the catalog data, is like URLs to pictures of this week's meals. Okay. That turned out not to be data we needed to send to them all the time. So we did some amount of sort of prefetching and caching for things that were medium-term data, and then that separated, the essential live customer interest data of record into its own cell. And that was not really a code. That didn't require a change to our infrastructure. That was just a twist on the way it was coded. The second thing that fell out of it, which I'm pretty proud of, is a library called CLJSON, which we wrote, I guess, over a year ago. But what it is a library that encodes Clojure data as JavaScript object notation, JSON, and then we use the native JSON encoder and decoder. The reason I'm proud of this is because we totally beat Rich and Crew to the punch on that technique. If you're familiar with Transit, they do the same thing. Of course, they do something much more ambitious because they support the scheme across multiple language platforms, and we only cared about Lisp.
Right. Are you still using CLJSON?
Yeah, we've been using it for over a year now, and it's interesting. It was I think my first foray into generative testing was attaching it to this because it's sort of the ideal library.
Nice.
Sorry, did you have a question?
Oh, I said no plans to switch over to Transit.
It would be great. I would love to switch to Transit because that's a whole huge, fairly complicated library that we no longer would have to maintain. Yeah. But I think it's early days. CLJSON has been working really well for us, and I plan and hope not to ever need to work in another language other than Clojure or ClojureScript for a while. So I'm lucky in that respect. But I think Transit will only get better and more polished, and I think it's only a matter of time before it becomes too awesome to pass up. So. I know, David Nolan has hand-coded huge swaths of that in JavaScript, and it's he's coded to particular performance aspects of this build of Chrome or whatever. So, sort of a level of craftsmanship I will never attain. So at some point we'll end.
Right. Excellent. Well, thank you so much. This
Sure.
was amazing.
Thank you.
Yeah,
Great.
thank you for being.
I'm glad you enjoyed it. I have a much better sense at this. Like I feel like I did not bomb. Like nobody walked out as far as I could tell.
No, this was fantastic.
That was amazing.
Yeah.
Great.
Thanks so much.
Sure. So I'll post some links on the meetup group. But thank you so much for coming and sharing your evening with me.
Thank you.
Thank you. It was our pleasure. Yeah.
You guys.
Thanks. Bye.